Okay, it's about time to start, and I figure I'll just go ahead and introduce myself while people are still coming in. I'm excited to be here. This is the first time I've made it to Saintcon. I've wanted to come for many years, and for some reason or other, I haven't been able to make it. So this is great. I love my new badge. That was fun to put together. So I have been really excited about OAuth for a while, and I've been working on it at Family Search, OAuth and OpenID Connect. And I've given this presentation many times with lots of different slants. And so if there's someone in here, if you have a real, if you're wanting to come away with something, I'm curious what it is that you want to learn more than anything about OAuth and OpenID Connect. Anybody? So no, what's that? You're interested in knowing the ugly. Okay, we'll get into some ugly parts of OAuth and OpenID Connect. There's certainly some controversy behind OAuth2, and we'll talk about that. So I'm guessing just you'd like a general overview of it. Any pen testers in here that would be interested in how to attack or test OAuth? You got one pen tester? Okay. All right. My name's Cam Morris. I'm a developer at Family Search. We use OAuth2 and we use OpenID2, which is not OpenID Connect. I've implemented OpenID Connect, and we're still rolling that out. It's not available to our partners yet. It is the largest collection of genealogy records in the world. We have 4 billion names indexed, but we have so many records that we're estimating that currently we're about 20 billion names still to go, and we're acquiring and making deals with lots of different organizations and countries, and that number keeps getting bigger and bigger. And so to really get all of this done, we're expanding out to partners. There are, you've probably heard of Ancestry.com, Find My Past, Mozilla, JanaeaNet. So we need to be able to integrate with these partners, and we do that with OpenID, or I'm sorry, with OAuth2 and OpenID. Also, completely incidental, I'm going to put another plug for my open source project. It's OWASP PassVault. It is a password policy tool. It's intended to replace your password policy. I'm a little biased, but I think it's the best password policy that I've seen. Probably the closest is a password strength meter by Dropbox. We do pretty similar things. And OWASP PassVault is getting better and better, and if you'd like to talk about that, I would love to share what we've done. It's pretty fun stuff. But back to OAuth2 and OpenID Connect. So here's kind of a history timeline. If you've been following the identity management and access management specifications, I was involved with SAML2 and kind of left and did a separate kind of career path, and then I've come back and gotten back interested into OAuth2. So on the black side of the scale here, you've got more SOAP and XML based specifications. And what's exciting to me as I come back and revisit this is it's the same stuff rehashed over and over. But each iteration, it keeps getting better. And I'm really excited about OAuth2. Certainly there are some ugly things that we'll get into. And there was kind of this revolt. Once we got to WS star, it was huge XML, SOAP. There were so many specifications, you needed a fleet of developers to implement in WS star, or you had to buy this huge monolithic system to get it to work. And so there was this huge revolt against SOAP and XML in general, not just WS star, that they went back to a more simple model. And OpenID was an effort in that way. And so I've kind of drawn circles on how big and complex these specifications are. So here's the XML, and here's the more REST-based specifications. OAuth2 came along, and it shook up everything because it was so simple and so brain dead, everybody wanted to do it. The ideas here were, this was back in the times where you'd have these web pages that would gather your Facebook credentials and then log in for you, and they do their extra add-on stuff, or for Twitter. And so this was obviously really bad, and so I'm glad that this isn't a problem anymore. But you wanted to be able to grant access to Facebook or Twitter or whatever to other third-party websites. We wanted to get rid of collecting their passwords. The nice part about this is there's no identity even needed. They just got rid of, you didn't care who the person was, you just granted them access. And so you had that nice ability that you could actually be anonymous at another site, and they could still use your resources on Facebook or Twitter. So the first thing that happened, everybody wanted to use it, and Google came along and they said, this is almost a little too simple. We need to add this. And then Facebook came along and said, we needed to add this. So you had these competing versions of OAuth, and none of them interoperated. And they said, hey, we should get together and make this a real standard. So they came along. Aaron Hammer is attributed to creating OAuth1, and he was on the specification board for OAuth2. And that didn't end all that well. So this is what he puts on his blog post. OAuth2 and the road to hell. They say the road to hell is paved with good intentions. Well, that's OAuth2. So this is when he announced his resignation from OAuth2, and these are some of the reasons why. They had changed it from a protocol to a framework. They wanted to be able to build more layers on top of OAuth, and he was frustrated with complexity and how hard it would be to make something interoperable. That was the first complaint. The second was tokens. In OAuth, he had the security token that was not a bearer token. It was a token that you needed to authenticate yourself to use. So if you're a third-party service, you wanted to use something at Facebook, you had to prove to Facebook that you were that third party that the token was issued to. And we'll get into that a little more. And the concern here was that only the big boys could really implement OAuth2. The big boys meaning Google and Facebook and Microsoft, which is ripe territory for security professionals to come in and find what's broken, right? So knowing these things, I think, is useful when you go in and look at someone who's implemented OAuth, so that you can see the failings that might be there. So here's kind of the overview, the terms that OAuth uses. You have a resource owner, the person who owns the pictures on Google or the YouTube entries. So the authorization server in that example would be Google. The resource server would be YouTube or the pictures, the Photos app. And the client, which is kind of frustrating to me that it's named client because it's a server. You could think of it as, in this example, let's say it's a photo publishing, a copy print shop, and they're going to make a photo book. So we're going to pull images from the resource server, and this print shop is going to make a photo book for you. So we're going to grant, the resource owner is going to grant access to the client so that it can access the pictures up on the resource server. So the client is the third-party server accessing your resources on the authorization server. So the authorization server and the resource server are coupled, if that makes sense. So we're going to get into the hardest part of this, and it's going to take about 5 minutes to get through the most complex part, and then the rest is a breeze. So there's 4 different ways you could do this. Code grant, is the most complex, but the most common use case. So we're going to go through that in depth, and then we'll kind of breeze over the rest of it. So you got your browser. This is a classic browser use case. So you have your browser, you're going to the client. In our example, it was the printing shop. So the client wants to redirect your browser with a 302, wants to redirect you to the authorization server. So you get redirected with this authorization request. If you're logged in, then you're prompted to ask, you grant this access to the client. And then when that happens, you get an auth code back in another redirect. So you get redirected back over to the client with this auth code. And the auth code is just a random number, just some bits. The authorization server has stored this auth code and remembered who he sent it to, which client he got sent to, and which user it was, so that when the client comes back to the authorization server with that auth code, he's able to exchange it for an access token. And the access token are the keys, is the key that you need to go to the resource server and get a resource. If you're familiar with Kerberos, this kind of has the same feeling. Like the ticket granting service. You're going to the authorization server, and there's two endpoints. I'm not sure if you can see that all that well. There's the authorization endpoint, that's the first circle there, and the second circle is the token endpoint. So the redirect goes to the authorization endpoint. That's what the user sees. And the token endpoint is what the client can connect to directly. So that's kind of a high level. We're going to zoom in on each message to get a little more deeper there. Any questions on the overall flow? Does this make sense? Great. Okay, so this authorization request that comes from the client redirects your browser to the authorization endpoint. In it, it's pretty simple. It's got these parameters in it. Response type says we're going to use the code flow. I mentioned there was 4 flows. This is going to be the first code flow. It has a client ID. The authorization server already knows who the client is through this identifier. The state is a prevention for cross-site request forgery. So if you're a pen tester and you see this state and you're checking to see if the client implemented this correctly, this state needs to be something not predictable. It needs to be remembered on the client so that if you did add a few characters on there, it should reject it. It should notice that the state got tampered with if you were to play with that. Scope is what the client is asking for. In this case, the client is asking to see images. And then you put a redirect URI of where you want the authorization server to come back to when everything's already been authorized. And this URI has to be validated. It has to be pre-registered. You can have several endpoints at the client, and this one will tell you the exact one that you want. So there's no open URL redirect here. So after that request comes in, you're prompted to log in. If you're already prompted to log in, you'll be prompted to give your consent. So this is the way it looks on Google. It will ask you, this client wants to manage your photos and videos. So you click allow, and then that response comes through the redirect again to the client. And the code is that random number, random set of bits. And then again, you see the state here, and it needs to be exactly the same as the way it came in to prevent that cross-site request forgery. So the client now has this auth code, and it exchanges this from the auth authorization server like this. So I have a basic authorization header, which is kind of nice that you can authenticate the client. It's optional. You don't need to. Because he has that auth code, authorization code, he can use that to exchange it. And that's proof enough that he had the right URL if it's over HTTPS. So that's optional, but a nice extra security and depth type thing. So you see the grant type. This time we're saying it's the authorization code. We put the code in there, and we repeat the redirect URL just for an extra step of validation. And then we get back the access token. The access token is of type bearer, which speaks to some of the controversy, some of the ugly behind OAuth2. It tells you when the token expires and gives you an optional refresh token. And we'll talk more about the refresh token in a second. So when you're using an auth code to get a resource, you can put it in an authorization header with the keyword of bearer, and then you put that authorization token in there. You can also pass it in as a parameter or in a form URL. So that is the overall flow. I can talk some more about the refresh token. Is there any questions on this flow before we go on? Does this make sense? Okay. So refresh tokens, because this is a bearer token, it doesn't require any proof to use it. Anyone who has it can use it. And so to restrict any kind of security problems with that, they're short-lived, as in minutes and not hours. So we have this new thing called a refresh token, so that when your access token expired, you can exchange that refresh token for a new access token. And the nice part about that is you're not storing passwords to keep an extended login type thing. Instead, you're storing this refresh token. So if this print shop isn't going to print off my pictures directly when I'm online, instead they want to access those pictures maybe a couple days later, they could use a refresh token to do that. So that is the real meat of OAuth. They have some other flows. Implicit grant skips a step, so that if you just have a JavaScript-only client or a public type client like an Android app or an iOS app where someone could get at there and you can't embed credentials in there for authentication. So this is a flow for public type clients, which is nice. So the big change is in that authorization request, instead of getting that code back, you just get an access token back directly. And then the JavaScript inside the browser can go straight to the resource server. And then you don't even need a back-end server in this flow. You can also use a password and go straight to the token endpoint and get an access token with that password. You could also get a refresh token with that access token, so that, like, if you're on a mobile client and you don't want to keep that password on there, you could use this to first time use the password and then get rid of it, and then use a refresh token for however long you need to keep them logged in. And there's one more flow for the clients to authenticate. And nothing too exciting there. So I'm going to move on. So back to the ugly. Yes, it's a framework. And I don't want to disagree too much because I really respect Aaron Hammer. Everything he touches gets simplified, and simple is great in this world of complexity and protocols. One thing that's nice about the framework is that they made it so that you could layer OpenID Connect on top of OAuth. You can take the simple protocol for granting access and layer identity on top of that, your single sign-on type use cases. The tokens, let's see, did we get to that? I got a slide for that. Oh, yes. Okay. So the bearer token versus a proof token. A bearer token is something, it's pretty simple, it's short-lived, but because it's short-lived, we've added this extra complexity with a refresh token, and you could easily argue that this is less secure. A proof token means once I've given you this token, you can only use it if you authenticate back. And OAuth did not shut the door on this. It specified a bearer token, but it also made it possible to create other types of tokens. So there is drafts and work in place to come up with a proof token. If that's a use case that you're really into, I'm sure you'll be able to find someone who can do that. They've certainly paved the way to do that. And some of the complaining was, crypto's hard. Who wants to sign and encrypt if you're a client? So they tried to push all the complexity into the authorization server and make it simpler for the clients. Okay. So the access token itself, there's two different strategies you could use, both with good and ugly. So you can have a simple handle. It could just be a random set of bits, in which case you need to be able to call home. So for example, Family Search has probably 40 back-end services that make up what you see as one web page. And so each one of those 40 services has to call in the case of a handle, it would have to call into the identity and authorization service in order to figure out who this person is and what access they have. Or you could embed all of that information inside of the token itself, which we would call an assertion. It's all self-contained. It asserts what the user can do. And there's a great spec called the JWT or JOT. They actually put the pronunciation of JWT in the spec, which I thought was kind of funny. So the official pronunciation is JOT. It can be, it's JSON data that is signed or encrypted. And this really came from the OpenID Connect push to be able to get a JSON-like token. So I'm not going to get into token storage. We're going to jump ahead. Oh yes, let's look into this. So here is, if you want to play around with how OAuth works, type in Google OAuth Playground. And you can go to this and you can see all of the scopes that they have exposed. We can get all kinds of AdWords and AdSense and cloud management. If we come down here, we'll find YouTube. So if you wanted to get access to someone's YouTubes that they have published, you could include this scope. This URL is, the full URL is a scope, and get access to somebody's YouTubes. So this is going to go through that whole process. I'm going to click Authorize API, and you'll see these same requests that we just went through. So it's going to see, I'm already authenticated, so I'm just going to pick which account. Let's go with my OWASP account. I didn't think of this. This is probably really small. Much better. Okay. So OAuth, this Google Playground is asking to access my YouTube account. And I did that through that scope. And I click Allow. And we'll be able to see the requests and responses come back here. So here is their authorization endpoint. You can see the redirect URL, how to come back. Here's the response type of code and the scope. It's URL encoded, so it's a little ugly looking, but here's the YouTube. And then you'll see here the response comes back with this code. At this point, here's our authorization code. We can exchange that for our access token. So here you'll see over here the access token. Right there, it's that random set of bits. And I don't think it's all that random. There's always one period in here which is similar to the JOT format, but not quite the same. So I've been curious of what their format of access token encoding is. You'll see it's a bearer token, you'll see when it expires, and the refresh token. So if I take this access token and then hit the REST endpoints for YouTube, then I'd be able to, the service, the client would then be able to pull down YouTube information. Okay, so that's scopes. So we're going to go now over to OpenID. And OpenID has a different set of terminology. Any questions on OAuth before we move over to OpenID Connect? Okay. So before we had the resource owner, the client, the resource server, authorization server, we got some new terms here. The authorization server is now called the identity provider, or the OpenID provider, OIDP. The client is the relying party. It's relying on the identity provider to give it identity information. And we get a new endpoint. We have the authorization endpoint, that's the small circle, it's probably hard to read. The token endpoint, and then the user info endpoint. And it turns out that with OAuth, the first thing that clients did, as soon as they got this authorization, the first thing they did with that access token was they hit this custom endpoint to figure out who the user was. So the nice part about OpenID Connect is it standardizes how that endpoint looks. So the authorization code flow, same flow as before, except we're going to add one new scope. We add OpenID to our list of scopes that we've asked for. So the result of that, after I exchange the authorization code to get back an access token, I also get an ID token. And we'll talk about what's in that ID token that makes it special. Implicit flow. Yeah, we can get into that. So implicit flow, you have the option to make it all JavaScript, just like in OAuth, except that you can also get an ID token. Well, because we have two things, we may want to mix and match. So they came up with what's called a hybrid flow. I may want to get the access token in the JavaScript, but I may want to get the ID token on the back end. So you can mix and match. You can get the code, you can get the token, or you can get all three if you really wanted to. So that's the hybrid flow. And for family search, we decided that less was more, and we completely, if you want to have an ID token or an access token in the JavaScript side, then you make another request. An extra request, for us, bought simplicity. So we like that approach. And this is, oh yes, this is showing that you can go to the user info endpoint. So the ID token has in it a subject, and that's kind of the key for single sign-on. And you can put additional user claims. This person has this phone number, this last name, this email address, a verified email address, things like that. Those are claims. They can be put in the token, or they can be accessible through this user info endpoint. So let's talk some more about single sign-on. This is advice around if you have to do passwords, do it once and do it with someone who's done it. who's done it right. So Ping, ForgeRock, Google, Microsoft, AWS, Unbounded, there's probably another dozen vendors that have done this, and it's probably worth the money to get it right, because passwords, as I'm sure we all know, they're toxic. So the more you can do single sign-on, I think the better. Cut down on the number of passwords flying around, and you have to do passwords in one spot. And then you can add the extra, the two-factor authentication, the FIDO, fancy passwordless authentication. You can do all that in your one single point of authentication, and then do single sign-on everywhere else. So the OpenID subject is kind of key. This is, given the OpenID provider and the subject they give you, you now have a unique identifier for that user globally. And we actually found a problem with this in a vendor that was implementing OpenID Connect. And the subject was a common name, which was a problem because the user can pick the common name. And if a user decides to leave that company or to terminate his account, say like somebody famous on Facebook, they decide, I'm done with this social media thing, it just hurts. So they quit Facebook, and then the next person to log into Facebook with that same name, if that name is put into the subject and you got single sign-on into a whole bunch of different systems, you can now resume where they left off. So that's a big problem. So the subject has to be unique and never reused. Okay, single sign-out. Here's another ugly spot. There's 3 draft options. I've seen the session management implemented, and they're now working on 2 additional drafts. One which is a HTTP-based, which would include redirects, or a back channel where you could go straight to the authorization server to log people out. And this is really well baked in SAML2 and in WS Star, but not so much in OpenID Connect yet. It's still in the works. So if you absolutely need to have this, then maybe I'd stick with your older SAML2 or WS Star type implementations. So that is OAuth and OpenID Connect. And I really was planning for more questions, so we have a little time left over. Any burning questions that you'd like to get addressed now? Well, excellent. Thank you.